Here in this test facility at NASA Ames Research Center at Moffett Field, California, a small group of researchers from NASA's Unmanned Aircraft Systems Integration into the National Airspace System project are working on a solution to a problem that will have a monumental effect on how some new aircraft fly here in the U.S. The problem they're working on is how to integrate still relatively new unmanned aircraft systems into our busy national airspace, also known as the NAS. Although they have been working on this plan for several years, their specific goal for this phase of testing is to develop minimum operational performance standards for ground control stations, or design guidelines, that will enable pilots of unmanned aircraft systems to detect and avoid other traffic. They plan to do this by implementing specific tests that will include human-in-the-loop experiments that will objectively measure UAS pilot performance. For most of us who fly, we probably don't think very often about the complex systems that are in place to get us from point A to point B. But suffice it to say that the rules and regulations for our national airspace are understandably some of the most stringent in use anywhere. So integrating something new into the system is incredibly daunting. Since 2010, this group of NASA researchers and their partners have been working diligently to do just that: integrate unmanned aircraft systems into the NAS.
So the unmanned industry wants to have access to the airspace and integrate with manned aircraft. But right now there are no rules that allow them to do so. And so we are looking at defining, along with the FAA, what the rules are that would allow them to fly and interact safely in the national airspace. One of the biggest problems in trying to integrate unmanned aircraft is that they don't have the ability to see and avoid other aircraft, as a pilot would through the cockpit windows. And so we have to provide electronically and through sensors that ability to see other aircraft, and then through our displays provide the guidance and alerting that allow them to maintain legal separation and stay well clear of other aircraft.
The term "well clear" is very important for the future of unmanned aircraft systems in the NAS. For manned aircraft, pilots are able to stay well clear of other aircraft through a combination of tools, which include using see and avoid techniques. See and avoid basically means a pilot uses his eyes to avoid any trouble that he sees. With unmanned craft, though, there is no pilot on board, so they will need to use a different approach called detect and avoid. A detect and avoid system will use a suite of complex sensors and radars on board to make sure the aircraft will stay well clear of any traffic.
Ultimately, this is a final validation of some of the work that we've been doing along the way, developing an alerting system, guidance for the pilots, and using algorithms that were developed in-house to perform that detect and avoid sequence. And so now we have, through several experiments, honed down on what we think are the minimum operating standards that are necessary to perform this task, and we're collecting data with real UAV pilots and real air traffic controllers to be able to test that and do full validation before we write the rules for operating in the airspace.
As Jay mentioned, to test this system, this team at NASA has set up complex simulations that use real data from air traffic control, real air traffic controllers, and real UAS pilots.
We have the pilots sitting at the ground control station, and we're really trying to replicate what a normal task load environment will look for the UAS pilot. So we have them flying a mission and a flight plan for them to follow and to stay on to complete their mission. And then they also have within the ground control station what we call secondary tasks. So they're responding to chat messages, and they're being asked to monitor various systems in the ground control stations. So we'll set up an encounter for them. Once the aircraft or the encounter that we've set up from gets close enough, it'll start being picked up by the sense and avoid processor, and that will provide alerting and guidance on the displays. And so then they will use the command and control interface in the ground control station to input a resolution maneuver, and they're going to use the maneuver guidance that we provide to them in the detect and avoid display to help them decide which maneuver is most appropriate, and they'll upload that to the aircraft.
Currently, unmanned aircraft systems only fly within restricted space here in the U.S. But as demand grows for unmanned aircraft systems to perform a host of important tasks, there will be a need for the pilots to understand the minimum requirements of the system.
What they're doing is really developing the standards so that industry can take the standards that are developed here and apply them. And who knows what industry comes up with. They might come up with something much better than we have right now. And that's the beauty of the way this is done, is NASA's not trying to build the final solution. We're trying to help guide industry and say, here's the minimum, but you can make it a lot better.
I think the team has been doing a really excellent job understanding what the UAS community needs, especially in the areas of detect and avoid and communication, and just expanding the state of the art. It's really providing that type of research information to just increase the ability for UAS to fly in national airspace.
Although the work being done by this team has been challenging, it is safe to say that their efforts will undoubtedly make the flying environment safer for all of us.